All right, everybody, we are going here. We're making this happen. So we got parentheses and trig functions, and this is something that trips a lot of people up as time goes on. So let me show you all the different ways that we can write something, and it can be a little confusing. So the first one is kind of like straightforward. It's pretty obvious that that's just cosine of 3x squared. So it's just cosine and then whatever's on the inside, right? But the second one is a little bit more confusing. So what does this actually equal if we were going to change this? Well, something that I've been bringing up lately is that you need to bring your algebra in front of your transcendentals. Transcendentals are things like cosine, sine, secant, logarithms, exponentials, anything that's like that. Algebraic is anything else. So the x squared should actually go in front by the commutative property of multiplication, and then we have cosine of the number 3. That's what that is. So that's a possible way of doing that. What type of rule would we have to use to do this problem? What type of rule would we have to use to do this problem? Yes? The product rule, yeah. Most likely the product rule, unless you knew cosine of 3 off the top of your head, and then it's just a constant that you could pull out. Technically, cosine of 3 is a constant, but you're probably going to use the product rule in this situation. You can use the product rule, by the way, on something like this if you ever wanted to. I mean, I don't know why you would, but derivative of the first times the second plus derivative of the second times the first, and it comes out to 2. So I have been known to use the product rule sometimes, not something that's as unnecessary as this, but something like that maybe. So sometimes you can use the product rule even when you don't necessarily need it. Okay, so let's go to the next one. Cosine of 3x squared. What do you think that is equal to? I mean, it depends on how you read it. Because I could say cosine of 3x squared and it sounds like it's the same thing as the top. Is it? No. What's being squared? No, the cosine is not being squared. This would make the cosine be squared, but the cosine is not being squared here. Only what's in the parentheses being squared. So this is actually cosine of, what's 3x all squared? 9x squared. That's what that is. Okay? The squared is not squaring the cosine in the third example. How about this one? Probably the most important one. This one's a big one. We can never ever forget what this means. So what does that mean? Yes?
Cosine x all squared.
Exactly. Cosine of x all squared. And that is going to be used with the chain rule quite a bit. So these are four actually different ways of looking at a problem that's kind of all jumbled around. And I think that sometimes these can get a little confusing. So be aware of these things because the examples that you do in this section from here on out are going to have a lot of this. You've probably already seen a little bit of that, right, to this day. So don't forget, pull transcendentals to the front, please. It's best if you can put parentheses with your trig function. We really like to have that because what happens is if you accidentally do something like this, if you write cosine of x times 5x, what you're telling me is what? What is this telling me? What are you saying here?
The cosine of 5x squared.
Yeah, it could be construed that way. I think when there's no parentheses, I don't really know. I believe that this is always assumed. This is technically saying that because they're going to put the parentheses around the whole thing. If you don't put parentheses, they're going to put it all in there if you don't put them. So I would recommend putting them because this is actually equal to cosine of 5x squared. Of course, some people would know what you're talking about and just give you a break, but I'm not always going to be like that. So be aware of that. Parentheses are good. So, okay, so let's look at this problem right here. Kind of similar to something we kind of talked about earlier in today. Does anybody want to tell me how they would like to rewrite it? What would you like to do here? Yes?
Sine 4t. Oh, well, 2. Well,
It's okay. Sine of 4t.
and then all.
Good. So I'm going to take this cubed and kind of just show you that this is this. Okay? So let's go ahead and do the red part first. So go ahead and tell me what I need to do for the red part. for my f prime of t. Also, does anybody know what this would be if I wanted to write it with the fraction? F prime of t is going to be the derivative of df dt. That's how you're going to say that, df dt. Might not be a bad thing to just be aware of. F is the function, t is the variable, t is the x, right? In a sense, the independent variable. Okay, the red part, how do we do it? Yes? It will be to the second afterwards, but we bring the 3, right?
Yeah.
Yep, so I'm just doing that. Bring down the 3, subtract 1. What happens with the inside? Yeah, nothing happens to the inside. Nothing happens. So we have sine of 4t. And now we have to focus on this. And we say, okay, well, I need to multiply by the derivative of this. So what's the derivative of sine of 4t? Yes? Cosine of 4t is the derivative. Perfect. So we know that the derivative of that is cosine of 4t. But we're not quite done, because what still has to be done? The derivative of the 4t, which is 4. So we multiply by 4. Now, cleaning it up. The kind thing to do here is to put all of the algebra in front of the transcendentals. So we'll take the 4 and the 3, and we'll condense those to 12. We'll take the sine of 4t, and we'll make it sine squared of 4t, with parentheses, and then cosine of 4t. Okay. The book could go a little excessive simplifying, but this is perfectly acceptable answer. Nothing wrong with that at all. All right? Questions? All right. So now we will go to the next page. I guess we're on the back. And we just got a few different types of things, logarithms, exponentials. So the first thing is the derivative of the natural log function. So this is just kind of something that you can memorize. So I'm going to show you the general derivative. The derivative, if y is ln of x, then dy dx is equal to. That is 1 over x. Okay, so the derivative of the natural log function is 1 over x. So that's something you're going to want to memorize pretty quickly. And it's going to complicate pretty quick with the chain rule. So now how do we deal with the derivative of natural log when it's not so easy? So I'll write a couple of things here. This is the easy or the basic type. This is the basic understanding. But now what you need to understand is how am I going to apply that in all scenarios, in all situations? So let's try another example, example 2, which is harder. And I'll make that example, let's see. Y is equal to, we have another one underneath, but I'll just do one, and then you can do that one. Y is equal to, I guess what I'll do, ln of 5x. So how do you find the derivative? Well, the rule for this is, here's a quick general rule. If y is equal to ln of something, so I'm going to put u as the something. That's a bunch of stuff, not just a variable, like a bunch of stuff inside, okay? ln of u. The way that you do this is you take what I said is 1 over u, and then you multiply by the derivative of, well, what do you think you multiply by the derivative of? U. So you do u prime, okay? So it's 1 over u, because I said the derivative of ln of x is 1 over x, so it's 1 over u. But you have to multiply by the derivative of whatever's inside. In this basic case, the derivative of x is 1, so you don't have to worry about it. But in other situations, you're going to have to multiply by that derivative. I'm going to show you something that you really probably want to memorize now. This is the deal. This is the chain rule understanding. This is the chain rule is important, but I'm going to show you something that you can just kind of skip around to every time. Oops, sorry, this is y prime. Y prime is also equal to, what would be a smart way of writing this? I mean, you have 1 over u times u prime. Yes? U prime over u. So what does that really mean? That means is that when you have ln of something, it is the derivative of the something over the something left alone. The purple is probably going to be more helpful to you, but it comes from the chain rule. It's not some mystical idea. It comes from the chain rule. But the purple is probably going to be more useful to you. So let's do this first the green way. Okay, so we'll start with this. So what do you think y prime is in this example? Well, it's 1 over what? 1 over 5x. And then what do we need to multiply by? times 5. Perfect. Good. And that works out to actually cancel and be 1 over x in this circumstance. This doesn't always happen. Now let's talk about the purple way. Well, what does the purple way say? Purple way says take the derivative of the stuff. Forget about the ln. The ln actually is going to, this isn't very mathematical, but it's going to go away. The ln is going to go away when you take the derivative. So what's the derivative of the inside? 5. What's the inside itself? 5x. And that cancels out to 1 over x. So both these answers are the same, but it might be helpful for you to remember the derivative of the stuff over the stuff. ln gone. Okay? So pause the video and give this problem a try. It's a nice little primer into this thing. So give that a shot, and we'll resume in just a second. All right, so let's go through this problem. So dy dx, the derivative of y with respect to x, is going to be the derivative of the inside all over the inside as is. So the inside is x squared plus 1. We just leave it as that. And the derivative of that is what? 2x. And we're done. That's all there is to it. That is how you do the derivatives for logarithms. The other thing we're going to need to talk about is e to the u. Well, if you think about e to the x, right? Let's just recap. So recap. Okay? If y is equal to x squared plus e to the x, or even 3e to the x, what is y prime equal to?
2x
Yep.
plus 3 e to the x.
Yes. So 2x plus 3e to the x. What's the conclusion? If y is equal to e to the x, whoops, what's y prime? Right, so y is e to the x, y prime is e to the x. The derivative of e to the x is e to the x. So what do you think the derivative of e to the u is? E to the u, perfect, very simple. But what if u had a bunch of stuff going on in there? If it wasn't simple as x, it was actually x squared plus 5 minus 11. What would you need to do? What's the inside? Do you think the e is the inside or the u is the inside? The u is the inside, so what do you need to multiply by? The derivative of u. You need to multiply by u prime. That's not a 1, it's a prime. So let's try an example. Is there one on the paper or no? Okay, let me give you one. Example. Y is equal to negative 5e to the x cubed, okay? So it's pretty straightforward. What is the derivative of negative 5e to the x cubed? Well, what do? You do nothing for e to the x, right? You do nothing. It's just negative 5e to the x cubed. But there's something that hasn't been done yet, and what's that? What's the inner? Right, the inner is x cubed, so we need to multiply by 3x squared, okay? This is all the chain rule, giving us negative 15x squared. We bring the transcendentals to the end, right? And then e to the x cubed, final answer, all right? So let's just kind of end there, but I'll give you one more example to try, just without me doing it for you. So try this, just find a little margin or some space there in the thing, and just give this a shot. I'll make it f is equal to, or I'll make it even f of x is equal to, let's make it the following, ln of x plus, or make it 3 ln of x plus e to the 4x, okay? So it's a little bit of each thing is happening here. I want you to pause the video and give this problem a try. All right, so remember, you're pausing the video, you're trying this problem, and now I'm going to give the answer. So, pause. Okay, so the derivative is f prime of x is going to be 3 times 1 over x. I'm just going to kind of show you that that's this derivative. Okay, and now here we have to do this guy. Well, we leave it alone, and then we take the derivative of the inside, which is 4. So let's try to simplify it a little bit. 3 over x plus 4 e to the 4x is the preferred way to have this. So that's what we've got. So that's pretty much it for this video. Hopefully you have a general understanding of the logs and the e's, the e to the x type of things, and how the chain rule applies to those. We'll see you soon.